All right, let's dive into a question that I think really gets to the heart of things for us as philosophers, especially when we think about knowledge and truth. So when it comes to even something like mathematics, which feels so certain, so solid, what are the, I guess, the ultimate standards for what makes something true in that realm?
Yeah, it's a really fundamental question when you think about it. Because as philosophers, we're constantly trying to figure out, well, what are the grounds for our beliefs? What are the things that we can point to and say, okay, this is why I'm justified in believing this. This is why I think this is true. And you're right, mathematics often feels like the most certain area of knowledge we have.
Exactly. It just seems so, I don't know, solid, right? But then again, you can have these very abstract mathematical concepts, and it makes you wonder if those same standards for truth apply there as well. So that's exactly what we're going to unpack today in this deep dive. We'll be looking at the Stanford Encyclopedia of Philosophy's entry on naturalism in the philosophy of mathematics.
It's a great entry, and it gets into some really fascinating areas that I think you, as a philosopher, will find really engaging. Because it's not just about, say, the specific methods mathematicians use. This deep dive is really about the bigger picture, how different philosophical approaches try to ground the very act of doing philosophy about mathematics. They're trying to answer the question, when we make philosophical claims about math, what are the standards we should use?
So we're going meta in a way. We're going beyond just like the specific theorems and proofs and asking, okay, what are the philosophical frameworks that help us make sense of those things?
Exactly. And the naturalistic perspectives we'll be exploring today offer some really intriguing answers. Some philosophers look to natural science as the ultimate authority, others find the standards within mathematics itself, and still others try to create a kind of bridge between the two.
This is where it gets really interesting because it's not always clear cut, right? Like, where do you draw the line between science and mathematics?
Yeah.
And where does philosophy fit into all of this?
It's definitely messy and complicated, but that's part of what makes it so intellectually stimulating. So let's start by breaking down one of the main approaches the article discusses: methodological naturalism. Now, it's important to be clear here that we're not debating whether a particular mathematical proof is correct or not. Within the system of mathematics, a valid proof is still a valid proof. What we're interested in is where the philosophy of mathematics gets its authority. Where do the standards come from for judging claims we make about mathematics?
Right. It's that next level up, looking at the foundations, not the specifics.
Precisely. And methodological naturalism in its various forms essentially says that these standards for philosophy of math come from somewhere else, either from natural science, from math itself, or from some kind of blend of the two.
Okay, so to make sure I'm following, we've got these different flavors of methodological naturalism. We've got scientific naturalism.
Which would be the view that the standards we use in natural science, things like empirical testing, observation, repeatability, and so on, those are the standards that should also guide our philosophy of mathematics.
Got it. Then we have mathematical naturalism.
Right. This one takes a stance that the standards for judging philosophical claims about math should come from within mathematics itself. So think about things like logical rigor, consistency, provability. Mathematical naturalists argue that these are the criteria we should use.
And then, to round it out, we have, oh, I've already forgotten what it's called.
Mathematical cum scientific naturalism.
Yeah, that one. It's a mouthful, but it basically tries to combine the best of both worlds, right?
Yeah. Exactly. It tries to find a way to integrate standards from both science and math. So it's this interesting middle ground. And one thing I find really interesting about the naturalistic perspective is that it often leads to what's called anti-revisionary consequences. Now, for a philosopher, this idea is really intriguing. It suggests that if you have some grand philosophical vision for completely overhauling or radically revising mathematics well, a naturalist would likely push back.
That almost seems counterintuitive to what we think of when we hear philosophy, right? Like, as philosophers, aren't we supposed to question everything?
That's a great point, and it gets at the heart of what makes naturalism so interesting, maybe even a bit provocative, because in a way, the naturalist is saying, look, we have these practices, these methods in science and math that have been incredibly successful in generating knowledge, so maybe we shouldn't be so quick to dismiss them or try to reinvent the wheel from scratch.
So instead of trying to come up with some completely new foundation for mathematics based on philosophical ideas, the naturalist might say, well, why not see how far we can go with the tools and methods that have already proven themselves successful?
Exactly. A great example of this tension between philosophical revision and naturalistic pushback that the entry discusses is intuitionistic mathematics. Now, this was a really ambitious program championed by figures like Brouwer and Dummett. They had these deep philosophical reasons for wanting to reconstruct all of mathematics based on the idea of mental constructions.
So essentially, they were saying that mathematics is ultimately grounded in the ways our minds can construct and grasp mathematical concepts.
Precisely. But this approach leads to a very different kind of math. It rejects certain principles, like the law of excluded middle, which states that every proposition is either true or false. And for many mathematicians and scientists, this intuitionistic approach seemed too radical, too limiting.
Because it would throw out so much of the mathematics that had already been developed and proven useful in science and engineering.
Exactly. And that's where the methodological naturalist comes in. They would likely point to this disconnect and say, well, look, classical mathematics, the kind that's been used to develop physics, engineering, computer science, all of that, it clearly works. It's been incredibly successful in describing and predicting the world, and even in advancing our understanding of mathematics itself.
So why abandon something that has such a clear track record of success just because we have some philosophical qualms about it?
Right. The naturalist would argue that, at the very least, we need some very strong reasons to overturn something that's been so demonstrably successful.
I can see how that line of thought could be quite compelling, especially for someone who's already inclined towards pragmatism or empiricism.
And this is where the historical development of these ideas comes into play. And it's particularly relevant for a philosopher who's interested in evolution of philosophical thought. The entry highlights Quine as being super influential here. His view was basically that we don't need some kind of separate first philosophy that sits above everything else and tells us what's real or how we should reason. Instead, he argued, reality and our best ways of understanding it are identified and described within science itself.
So science is not just one way of knowing among many. For Quine, it's the primary or even the only reliable source of knowledge about the world.
That's a good way of putting it. And Putnam had a similar line of thinking. He was really critical of what he called trans-scientific methods, the idea that there could be some kind of standard for judging knowledge claims that's somehow superior to or outside of the methods we use in science. From this naturalistic perspective, because mathematics is so deeply woven into our best scientific theories, they argued that the philosophy of mathematics should also be guided and, in a way, constrained by scientific standards.
It's almost like science gives mathematics a philosophical legitimacy in that way.
Right. And this is particularly interesting when you consider that both Quine and Putnam actually used this kind of reasoning to support Platonist mathematics, the view that mathematical objects like numbers and sets really exist, even if they exist in some abstract realm.
So they're saying that because mathematics is so vital to science, and because we have good reasons to believe in science, we also have good reasons to accept the existence of these mathematical entities that science seems to rely on.
Exactly. Now, as a philosopher, it's also important to consider the empiricist tradition here, which in many ways was a kind of precursor to modern naturalism. Thinkers like Mill and Hume also emphasize experience as the ultimate source of knowledge. But there are some important differences, especially when it comes to how they understood math.
Right, because they often tried to reduce mathematics to something directly based on sense experience. Like, the number 2 is just a label we give to collections of 2 physical objects.
Yeah.
But most modern naturalists think that that approach is pretty problematic and ultimately doesn't really work.
Exactly. They think it's too simplistic and can't really account for the more abstract and complex parts of mathematics. So, while there are some similarities, contemporary naturalism has really moved beyond that kind of strict empiricist view of math.
All right, well, let's fast forward then. What does naturalism look like in the present day?
Well, the SAP entry points out that there's been a surge of interest in naturalism within the philosophy of mathematics in recent decades. It mentions key figures like Burgess, Rosen, Maddie, Resnick, and Shapiro, who have all been grappling with these ideas in really interesting ways. And it even includes this helpful table that lays out these different versions of naturalism and how they apply to what it calls mathematics proper versus the philosophy of mathematics.
Okay, now hold on. As a philosopher, I'm always wary of these distinctions. What exactly do they mean by mathematics proper versus the philosophy of it?
It's an important distinction. Mathematics proper is basically what mathematicians do they. Proof theorems develop new concepts, solve problems within the existing framework of math. Think of, like proving Fermat's last theorem or working on the Riemann hypothesis. The standards there are really internal to math: logical rigor, consistency, the ability to derive new and interesting results.
Okay, so that's the actual doing of math. So then philosophy of mathematics is.
The philosophy of mathematics steps back and asks these bigger questions about the nature of math itself. Like, what are mathematical objects? Do numbers really exist? What's the relationship between math and the physical world? Why is math so darn good at describing the way things work? These are philosophical questions about math, not questions within math itself.
So for a philosopher, it's about understanding the foundations and the assumptions that underpin mathematical practice.
Exactly. And this distinction is really helpful for understanding how these different naturalistic approaches play out. So you can imagine, like, if a mathematician proves a new theorem, like the Green-Tau theorem, which says that you can find arbitrarily long arithmetic progressions of prime numbers.
Wow, that's a mouthful, but I think I get the gist. So we've got these prime numbers, and they're arranged in a specific way.
Right. So if a mathematician proves that, all these naturalistic philosophers would agree that the proof itself is judged by mathematical standards. Like, is the logic sound? Does it follow the rules of the game, so to speak? But then if we ask a philosophical question about that theorem, like, does the number 2, which is crucial for understanding primes, really exist out there in some Platonic realm? That's where these different stripes of naturalism will lead to different answers.
So some might look to science for the answer, others to mathematical practice, some to a blend of the two.
Precisely. And this is where things get even more intricate because we have to unpack this idea of authoritative standards. What does it really mean for scientific or mathematical standards to hold authority in the philosophy of math? The SEPI entry does a great job of breaking this down and identifying 4 key readings of the authority claim. We have biconditional, trumping, emphasis, and compatibility naturalism.
All right, I'm ready for a challenge. Let's tackle those one by one. What's biconditional naturalism all about?
So biconditional naturalism is basically the strongest claim here. It's saying that a philosophical statement about mathematics is acceptable if and only if it's sanctioned by whatever we've chosen as our authoritative standard. Whether that's science or math or some combo, it's like a two-way street. If it aligns with the standards, it's good. If it doesn't, it's out. No exceptions.
Okay, so that's a pretty strict view. What about trumping naturalism? How does that differ?
So trumping naturalism is a little less strict. It says that if a philosophical claim is endorsed by our chosen standards, then we should definitely accept it. But it leaves open the possibility that there might be other philosophical claims that are also acceptable, even if they're not directly given thumbs up by those standards.
So it's like, well, if science or math says it's good, then it's definitely good. But there might be other good stuff out there that just hasn't gotten the official stamp of approval yet.
That's a good way to think about it. Burgess and Rosen, the philosophers we mentioned earlier, their view is a good example of this kind of trumping authority, where they argue that philosophy ultimately has to align with what they call the firm and unified voice of science and math.
Interesting. Okay, what about emphasis naturalism? What's the emphasis there?
This one is even more flexible. It's saying that we should simply give more weight or more credence to the standards from science and math when we're assessing philosophical claims. It's not a hard and fast rule, but more like a guiding principle for how we prioritize different kinds of evidence and reasoning.
Got it. So it's more about tilting the scales towards a scientific or mathematical perspective without completely excluding other viewpoints. And then finally, we have compatibility naturalism.
Right, and this is the view that's most widely accepted in contemporary philosophy of mathematics. It's the most basic requirement, really. It just says that our philosophical views about math shouldn't directly contradict well-established scientific or mathematical principles. It's about making sure that philosophy and these other disciplines are playing on the same team, so to speak.
So it sets a kind of boundary, like, okay, you can have your philosophical ideas about math, but don't go claiming things that completely fly in the face of what physicists or mathematicians have already figured out.
Exactly. A good example here would be a philosophy of time that completely clashes with Einstein's theory of relativity. That kind of view would likely be met with a lot of skepticism, even among philosophers who aren't diehard naturalists.
Now, one thing that strikes me as a potential issue for naturalism is this question of boundaries. Like, where exactly does science end and non-science begin? Where's the dividing line between mathematics and philosophy?
It's a great point, and it's what the article refers to as the boundary problem. It's a tough one, and it gets even trickier when you consider that in the real world, these boundaries are often blurry. Like, think about a mathematician who's not only proving theorems, but also writing essays about the beauty of math or its history. Where do you draw the line between the doing of math and philosophical reflection on math?
It can get pretty messy.
Totally. And to make things even more complicated, there's this ongoing debate about whether there even is a single unified scientific method. The article mentions Quine's famous list of scientific virtues, things like empirical adequacy, simplicity, ontological economy as potential standards. But it also points out that those lists can be kind of vague, and they don't always offer a clear-cut recipe for how to weigh these principles against each other.
Right, because sometimes those principles might actually conflict. Like, what if the simplest explanation is also the one that requires believing in a lot more entities? Which principle wins out then?
Exactly. And on top of that, from our perspective as philosophers of science, we have to acknowledge that fields like science studies have really shown us that the actual practice of science is super complex, with lots of different methods and standards being used across different disciplines.
So the idea of this monolithic scientific method that applies to everything from physics to psychology, that might be a bit of an oversimplification.
I think so. Now, that doesn't mean that naturalism is completely sunk. Naturalists have some potential ways to respond to this boundary problem.
Oh yeah, let's hear them. How do they wriggle out of this one?
Well, one common response is to say that even if the boundaries aren't perfectly sharp, we still have a decent working understanding of what's generally considered science and what's generally considered math.
It's like, sure, there might be some gray areas, but come on, we're not completely clueless about what counts as science versus, say, astrology.
Exactly. And another response is to say that even with these blurry boundaries, naturalism can still function pretty effectively. The focus is on the core principles and methods of these disciplines, even if there might be some fuzzy edges.
Okay, but let's push on this a little further. What if science itself, or even mathematics, doesn't operate with a single unified set of standards? Like, what if the standards of evidence and explanation in evolutionary biology are totally different from those in quantum physics? What happens to the idea of scientific naturalism then?
That's another really crucial point, and it gets at the heart of what makes naturalism tick. If science or math ends up fracturing into all these little subdisciplines, each with its own unique and potentially conflicting standards, then this idea of a unified scientific naturalism becomes really shaky.
Because the naturalist is banking on this idea that there's some underlying unity to the way science or math works, right? Like there's some shared set of standards that gives those disciplines their authority.
Exactly. So if that unity crumbles, then the foundation of naturalism starts to look pretty shaky too. To really defend their position, naturalists would need to provide a strong argument for why we should believe that there is this underlying unity, even if it's not immediately obvious.
Otherwise, they'd have to accept that naturalism is a lot more fragmented and diverse than they might have initially thought.
Right, each little pocket of science or math would have its own corresponding brand of naturalism.
Okay, so another interesting wrinkle here, and this is something that, we as philosophers often grapple with, is the idea that in both science and math, you often have degrees of support for claims rather than just black and white answers.
Absolutely. In science, you might have a new hypothesis that's supported by some initial evidence, but it needs way more testing and scrutiny before the scientific community accepts it as like a well-established theory. And in math, you have things like conjectures, which are statements that seem plausible but haven't been formally proven yet.
Like Goldbach's conjecture that any even number greater than 2 can be written as the sum of two prime numbers. Mathematicians have tested it for tons of numbers, and it always seems to work. But no one's been able to come up with a formal proof yet.
Exactly. And that kind of non-deductive support, based on things like computational testing or finding lots of examples that fit the pattern, it provides a kind of probabilistic support, even if it doesn't give you absolute certainty.
So a sophisticated naturalism needs to be able to deal with those shades of gray, right? It can't just be about, like, this claim is either sanctioned by science or maths or it's not.
Absolutely. It needs a more nuanced way to account for those varying degrees of support. Some philosophers have looked to Bayesian confirmation theory as a potential tool for understanding how those degrees of support work and how they factor into our acceptance or rejection of different claims, even in the philosophy of math.
I can see how that could be a helpful framework. Okay, so another thing that's always fascinated me, and I think it speaks to the complexities of both philosophy and, human psychology, is this idea that what scientists or mathematicians personally believe isn't always perfectly aligned with what the official standards of their field would say.
You're talking about that gap between official methodology and individual conviction, right? Like, a mathematician might have a strong hunch about a conjecture, but they can't prove it yet.
Hmm.
Or a physicist might feel deep down that a certain interpretation of quantum mechanics is the right one, even though the evidence isn't quite there to back it up.
Exactly. And that's something that always makes me wonder, like, how much of our beliefs, even in these seemingly objective fields, are shaped by things like intuition, personal biases, or even, dare I say, philosophical assumptions that they might not even be aware of.
It's a really fascinating question, and I think it's one that philosophers of science have been grappling with for a long time. Like, how much of scientific knowledge is really shaped by social factors, cultural influences, or even the individual personalities of the scientists involved?
It definitely complicates this idea of science or math as this purely objective, perfectly rational enterprise.
No doubt. But naturalists do have ways of responding to this. One common argument is that the authoritative standards, whether they're from science or math, reflect what practitioners are disposed to correctly believe qua practitioners. So it's not about what individual scientists or mathematicians happen to believe at any given moment. It's about what they're likely to believe when they're really engaging in that discipline, using its methods and tools rigorously.
So it's like, okay, sure, scientists and mathematicians are human, they have biases, they have hunches, but when they put on their scientist hat or their mathematician hat and really engage in the practices of their field, then the standards of that field will guide them towards the truth, even if they have some personal doubts or disagreements along the way.
That's a good summary. And it also connects to the idea that knowledge is social. It's not just about what's going on in an individual's head, it's about the shared practices, the methods of testing and evaluation that communities of scientists and mathematicians use to build knowledge together.
All right, so the essay entry also broadens the scope a bit by touching on forms of naturalism that go beyond just science and math.
Right. It gets into this idea that maybe we should also consider insights and standards from other fields, like the social sciences, linguistics, cognitive science, even things like history and anthropology.
So it's this vision of a more expansive naturalism, one that recognizes the diversity of methods we use to understand the world and ourselves.
Exactly. And Quine, in his later work, definitely leaned in this direction. He started to see naturalism as encompassing this much broader range of empirical inquiry. And Penelope Mattie's idea of second philosophy really pushes this as well, advocating for a really engaged and collaborative approach between philosophy and all sorts of different scientific disciplines.
All right, so as a philosopher, I'm curious, how might this kind of broader naturalism impact our understanding of the philosophy of math specifically?
Well, it could have some pretty significant consequences. For instance, if we start to consider semantics, the study of meaning and language as part of our naturalistic toolkit, it could potentially provide new arguments in favor of mathematical realism.
Interesting. How so?
Well, think about the way we talk about mathematical objects. It often mirrors the way we talk about regular, concrete objects in the world. Like, we say things like, there exists a prime number greater than 100, in the same way we might say, there exists a cat on the mat.
So, the argument is that this kind of linguistic similarity points to a deeper ontological similarity.
Yeah.
If we talk about numbers in the same way we talk about cats, maybe it's because both numbers and cats are real in some sense.
Exactly. And that's a kind of argument that some naturalists find compelling. But of course, it's not without its critics. And this broader approach also introduces a new set of challenges because now you have to figure out how to deal with potentially conflicting standards from all these different disciplines.
Yeah, like if physics says one thing about the nature of reality and linguistics says something else, how do we decide which one to go with? Or how do we reconcile those different perspectives? It's like herding cats, but with academic disciplines.
Exactly. And this is particularly tricky for those mathematical come scientific naturalists who are trying to balance standards from both science and math because sometimes those standards might clash. Like you have this scientific principle of ontological economy, the idea that we should prefer explanations that posit fewer entities that are kind of more streamlined. But then you have these mathematical principles that sometimes seem to push in the opposite direction.
Yeah, like in set theory, where you have these axioms that posit the existence of these huge, mind-bogglingly large infinities, that doesn't sound very ontologically economical.
Not at all. And Maddie herself has argued for the principle of maximize in set theory, which basically says go big, posit as many sets as you can, consistent with the other axioms. So it's a kind of tension between like the scientific impulse to keep things simple and the mathematical drive to explore these vast conceptual spaces, even if they seem a bit extravagant from a scientific perspective.
All right, well, I think we've done a good job of unpacking what methodological naturalism is all about, from its various flavors to the thorny issues it faces. Now, the big question is, why would any philosopher be drawn to this view in the first place? What's the appeal?
It's a good question, and the article points out something that I think is often overlooked naturalism, even though it's often perceived as a conservative stance, one that defends the status quo. It can actually be pretty revolutionary in some respects.
Now, that's intriguing. I usually think of revolutionary as being the opposite of conservative.
Right. But consider scientific naturalism for a minute. It's saying that we should use the standards from science to evaluate and potentially even revise the way we do math. That's not exactly standard practice in the math world.
So it's revolutionary in the sense that it challenges the traditional autonomy of mathematics. It suggests that mathematicians shouldn't just get to decide what counts as good math based on their own internal criteria. They need to also consider the implications of their work for science.
Exactly. And this challenges some very deep-seated intuitions about the relationship between those disciplines. A good example here is the debate surrounding large cardinal axioms in set theory. Mathematicians typically decide whether to accept those axioms based on purely mathematical criteria, like do they lead to interesting theorems? Do they help us unify different parts of math?
So it's about internal consistency and fruitfulness within mathematics itself.
Right. But a scientific naturalist might come along and say, well, hang on a minute. Those large cardinal axioms might be mathematically elegant, but do they actually have any empirical consequences for our best scientific theories? If not, then maybe we should be skeptical of them.
So they're bringing in this external scientific perspective to evaluate what's going on within mathematics.
Exactly. And that can lead to some pretty radical reinterpretations of even very foundational mathematical concepts. And then you have mathematical naturalism, which on the surface might seem conservative. It's not trying to change the results of math. It's basically saying, look, let's just see what mathematicians do and let's use their practices and beliefs as the standard for our philosophy of math.
So on the one hand, it's conservative in the sense that it's taking existing mathematical practice as its starting point. But on the other hand,
It's saying that philosophy doesn't get to dictate to math. If mathematicians as a community accept something like Platonism, the belief that mathematical objects really exist, then that's the default position for the philosophy of math as well. No need to try to prove or disprove it from some external philosophical standpoint.
so it's almost like a kind of deference to the authority of mathematical practice.
That's a good way to put it. And I think that's what makes naturalism so fascinating. It's got this potential for being both conservative and revolutionary, depending on which flavor you're talking about and how you interpret it. But this inherent revolutionary potential also underscores the need for strong arguments in support of it.
And that leads us to the next point the article brings up, which is this. There's a surprisingly small number of fully developed, rigorous arguments for naturalism in the philosophical literature.
That's right. It's kind of an odd situation. Many philosophers who consider themselves naturalists, they just sort of state their position and then go on to explore its implications. But they don't always do the hard work of explaining why we should accept naturalism in the first place.
So it's like they're assuming that everyone's already on board with the naturalistic program, and the only interesting questions were about how to work out the details.
Yeah, something like that. And I think the article is right to point this out. Given the potentially radical implications of naturalism, it seems like we need more than just a few passing remarks about why it's the right approach. We need some solid arguments, some foundational reasons for why we should buy into it.
And that brings us to the arguments that have been put forward. One of the most common motivations for naturalism is this claim that science and math are just the most successful ways of knowing that we have.
Right. And this is where we as philosophers need to put on our critical thinking hats and ask, okay, but what do we even mean by success in this context? How are we measuring that?
Exactly, because you could imagine a group of people who have some bizarre belief system, and within that system, their beliefs are all internally consistent, and they lead to all sorts of predictions and explanations that they find satisfying. But that doesn't necessarily mean their beliefs are true or that their methods are actually reliable.
The entry uses the example of guruology, which is
Right.
like a made-up system of belief where the only standard of truth is what the guru says. So by its own internal standards, it might seem very successful because all the followers agree with the guru and everything fits together neatly. But that doesn't mean it's actually a good way of understanding the world.
It's like measuring the success of a cult based solely on how many people join and how dedicated they are to the cult leader. It doesn't tell you anything about whether the cult's beliefs are actually true.
Exactly. So the naturalist who wants to appeal to the success argument, they need to be a lot more careful here. They need to explain what they mean by success in a way that doesn't just assume the conclusion they're trying to reach.
Right. They can't just say science and math are successful, therefore they're the best ways of knowing, therefore naturalism is true. That's circular reasoning.
It is. They need some independent criteria for what counts as success that doesn't already presuppose the superiority of science and math. And even if we could agree on some objective way to measure the success of science and math, there's another problem lurking here. Why should the success of those disciplines in their own domains automatically give them authority when it comes to addressing philosophical questions about mathematics?
It's like saying, well, biology is really good at explaining how life works, so biologists should also be the authorities on the meaning of life. Those are just different kinds of questions, and success in one area doesn't necessarily translate to expertise in another.
That's a good analogy. So even if science and math are the most successful ways of knowing within their respective domains, it doesn't immediately follow that they should be the ultimate standards for philosophy.
Okay, so that's the success argument. What's next on the list?
Well, another argument for naturalism focuses on the idea of agreement. The thought here is that within science and math, you tend to see a lot more consensus on fundamental issues compared to the constant disagreements that characterize philosophy.
Yeah, that's definitely true. Like, you don't really see physicists having huge knockdown, drag-out fights about whether the laws of thermodynamics are true.
Right. But as the article points out, that doesn't necessarily mean that science and math are getting at the truth because they have more agreement. It could be that they have more agreement for other reasons, reasons that have nothing to do with truth or accuracy.
Like maybe they just have better PR. Yeah. Or maybe there's more social pressure to conform to the mainstream view. Or maybe the methods of science and math just make it harder to disagree, even if you have legitimate reasons to do so.
All of those are possibilities, and a philosopher will immediately recognize that just because everyone agrees on something doesn't mean it's true. You know, think about totalitarian states, where everyone's forced to agree with the government's propaganda, even if it's obviously false.
So agreement on its own isn't a very convincing argument.
Not really. But some naturalists try to make the argument a bit more sophisticated by appealing to what's called the tractability of disagreement. The idea is that disagreements in science and math are more likely to be resolved by applying shared methods, using evidence, appealing to logic and reason.
So it's not just that they agree, it's that
Yeah.
they're